Hello everyone, Assalamu alaikum. Here is Tawqir Nasir. We are going to discuss today the most important chapter of CSWIP 3.1, chapter number 3, named as Welding Imperfections or Welding Defects and Material Specifications. Please be informed that this is one of the most important chapter by considering the CSWIP exam, because if you gone through with the concept of all these welding defects, then you may clear the 40% of the entire course. That's why I would like to request you to see and watch this chapter very closely and be focused. Make sure you have the pen and copy in your hand, because I will discuss all the important points by considering the examination point of view. You should have to note down, you should have to make the notes. These notes will be helpful for you in your real exam of CSWIP. In addition to, I would also request you to subscribe my channel and press the bell icon to not missing any important video in future. Also like the button and share my video with your colleagues who needs this chapter or who needs the entire series of CSWIP, because this is totally free of cost. Let's start the Welding Imperfections and Material Inspection chapter. In this chapter, once I will elaborate all these things, then you will able to understand the types of welding defects, how many defects you have, and you should have also be able to understand the acceptance criteria on which defects we can accept any product or welding, and we can reject at any criteria limit. First, look here. Welding defects. What is welding defect? Guys, welding defect are any problem or imperfection. Imperfection means not perfect welding, which cause any problem in the welding in the future. Like if we have a welding, here we have welding. Suppose we weld two metals. After few months, few years, the welding got cracked or any other defects occurred. Due to that, the proper welding got disturbed. It means the joint which we made is going to distract or disturbed. This is known as defect, the welding imperfection. Now we will discuss how many kinds of welding imperfections, what is the impact on the welding due to that defect, and please consider these three things. One is, what is welding defect? Which kind of welding defect is it? You have to clear the concept. If you clear the concept, then second point is, from which causes this defect or any defect occurred, means causes, source, we can say source. So we will understand the causes, how many causes, how we can prevent this. The third one is prevention. So these 3 points we will focus most importantly. What is the kind of welding? What are the causes of that defect? What is the kind of defect, causes, and preventions? So by considering these 3 points, we will discuss all the welding defects, and believe me, if you gone through with it, you will able to clear the 40% exam. That's why I am again emphasize this. You should have to note down all these important things, watch the entire lecture, and also save all the important data in your notebook. Right, this is our ideal weld. Ideal weld means which there no defect. The toe height, the cap height, the root, there is no penetration problem or something. This is the ideal weld and acceptable for all parties. Here we have the crack. I will elaborate one by one further. What is crack, how it occurred, how we have to prevent. This is the porosity. What is porosity? In which weld porosity can occur, in which material the porosity could be occurred, like this. Then we have the undercut. What is the undercut? As Named, actually all the defects elaborated by their own names. Crack means any crack occurred, porosity means spots, undercut mean any undercut which due to in the parent metal. I will elaborate further. The slag inclusion mean there is something which included in the original welding is known as inclusion, and if it is slag then slag inclusion. Overlapping means from original weld something overlapped like this. Then we have incomplete fusion. Fusion means proper heating and welding. If it is not properly heated and welded, it means that it is incomplete. Incomplete penetration. Penetration means when you start the welding, then all the weld metal should be penetrated in the groove. It penetrated means inserted properly. If it's not penetrated properly, it means this is incomplete penetration. Then we have spatter. Spatter means dots of at any associated boundary of the welding is known as spatter. One by one, here you can see we have two parts of any metal. Then we joint it with butt welding. If you don't know about the butt welding, fillet welding, etc., parent metal detail, then please go to my previous chapter 2, which already uploaded at the YouTube. I will also mention in the description link. You can also check it. So cracks are actually in the weld metal if there is any discontinuity. Like here we have complete welding. This is the welding. Here you can see a line occurred. This is actually not a line. This is the boundary which differentiate the two states of the weld, like this one and that one. Between this, if any kind of gap occurred, it's known as crack. Then we have further different types of cracks. I will explain you. Just at first stage, just get the overview. Then we have undercuts. Undercuts means in the welding, is there any incomplete fusion or properly our weld is not completed, then it's known as undercut. Then we have crack, different types of crack, like crack can be occur. This is the our ideal weld metal suppose. Here we have the root. In the root, if crack occurred, it can occur in the fusion line, it can occur in the longitudinal line. Longitudinal crack means in the axis of the weld. If it's occurred at the crater, crater means the top layer of the root. If you don't know about these terms, then I will suggest you to go for chapter 2 first. Then transverse. Transverse means any crack which is transversely of the welding. This is the original welding. Transverse means at 90 degree. This is known as transverse weld. Transverse crack. Then we have penetration. What is penetration? If the welding not penetrated in the groove, welding groove, like these are the practical pictures you can see. Up to here, it's not completely penetrated. Then some penetration, some dot, some again gaps. Here you can see this is a root gap. This is completely unfilled. So we can say this is the lack of penetration in the root, right? You can see here root is completely not welded. Then we have undercuts. Undercuts, this is the original welding. If there is some gap between the parent metal and the gap welding, then it's known as undercut. Then we have concave root, means from root, if we have root of any welding and it's like this, concavity generated but welding started here. So this area where the concavity generated is known as concave root, like this. Then we have arc strike. Arc strike means like unconsciously, if the electrode touch with your base metal or parent metal, then it causes some spots. These are known as arc strikes. With the passage of time, these arc strikes can be penetrate in the material, which could cause the problem. These are the spatters. In original welding, when you are welding, if you have different due to different causes, like if you are overcurrent, if you have the more welding speed, if you have welding pool, a molten metal pool is more thick, and these are due to these problems. Then we have the burn through, like if we are doing welding, right, we started the welding here. If we have more current, then little bit spot generated and go to outside, this is known as actually the burn through. Then we have the slag inclusion. This is like a slag inclusion. It could be at root, it could be in the interpasses, it could be at the top side, any area. Then we have the porosity. Porosity is actually the small dots or the small circular, elliptical or elongated pores which normally generated due to oxidation, or if you have your material is contaminated from the oil, water or any contaminated material, then such kind of problems occurred. Then we have same specters, etc. Okay, then we have lack of fusion. Remember, whenever the word fusion came, fusion means properly welding. If it is lack means not properly, lack of fusion, not properly fusion, not properly welding material occurred. So if it is in the side wall occurred, then we can say lack of fusion in the side walls. If it's bottom, then we can say lack of fusion in the root. If it is top, then we can say lack of fusion in the top or the cap. Then we have overlapping. You can see originally this is the width of the welding, but here you can see the excessive welding occurred on the base metal. It's known as overlapping. Again, these are the undercuts. Okay, then we have the excessive root penetration. If we have more current at the electrode, then more weld metal occurred, and if it passes through the root face excessively, you can see here these are the prominent and extruded areas of the weld metals. So such kind of defect known as excessive root penetration. Excessive means more. Root penetration has specific area. If it's more, then this problem occurred. It's normally due to economical loss, means wastage of electrodes, more or less, because electrodes also waste. Then we need to grind this area, so grinding material will also waste, wastage of time. Then we have lack of root fusion, as I already described. If the penetration not occurred, fusion not occurred in the root, this is known as lack of root penetration. You can see here, this is here we have the proper welding, but here we don't have, so this is lack of root penetration. Let's start the here. You can see weld cap width, this is root bead width, this is root penetration from the base metal, bottom side of the base metal. From the top side of base metal, excessive penetration means excessive weld metal. If we have extra, if you don't know about these terms, then again I would like to request you to go for chapter 2. That chapter is most important to understand for this chapter and entire further CSWIP. So those chapters, chapter 2 is also important. First see the chapter 2 and again come back for chapter 3. Okay, butt weld. You can see here we have toe. Toe is properly blended. This is ideal perfect weld. If the toe is not properly welded, here you can see the blend of toe faces are not even, so this one is actually acceptable. Okay, here we have starting the welding defects, which we previously discussed. Incomplete root penetration. See, up to here we have root. If this area remain unwelded, then it's known as root penetration. What could be the causes? As I said we will discuss the concept of defect, then causes, then its rectification plan. Causes could be toe too small or root gap, means if we have a root gap too small, like we need 3 to 4 millimeter root gap and this root gap is 1 millimeter, it means the gap is too small, then the fusion will not occur in the root. That's known as root penetration. Penetration is not properly. The second thing could be arc length too high, means if we have far away the electrode and here we have base metal, the distance from arc electrode to the base metal or arc length too high, it means that we have less temperature. Remember, if we increase the arc length, then temperature will be reduced. If the acting temperature will reduce, but the arc width will be increased. You got my point? Arc width will be increased, but temperature on concentrated point will reduce. Due to that, the penetration will not occur, means fusion will not occur. So if arc length is too high, wrong polarity. Polarity means we have two normally polarities, positive and negative. We reverse polarity and forward polarity are direct current electrode positive. This is reverse polarity, and if we have direct current electrode negative, this we have reverse polarity. By considering the different welding process, we decided which polarity we need to prefer. Suppose in SAW welding, or if we have MMA welding, manual metal arc welding, then we prefer the DCEP, direct current electrode polarity. In this reverse polarity, also it's known as reverse polarity. In this polarity, 70% of heat generated in the electrode and 30% in the base metal. That's why we need more heat in the electrode for welding. So different, actually by considering the different weldings, we decided the polarities. So if we need direct current electrode positive polarity or reverse polarity, and we do it negative polarity, suppose forward polarity, then the heat generated in the base metal and electrodes will be different. So this will be the lack of fusion. I hope you got these points. If you understand these terms, all these things repeat in the defect, so be conscious. Electrode too large for joint preparation. Electrode too large means length of electrode is more as compared to the standard one, so we need to mention the understand the electrode length as well. Incorrect electrode angle, suppose as per the design or the drawing we need to weld at 30 degree, but we are welding at 60 degree. It means that this problem can occur. Too fast speed of travel for current. If our welding speed should be like 5 millimeter per centimeter per minute, suppose, but we are welding 7 centimeter or 8 centimeter per minute, which means that travel speed of welding is 2 more, then less heat generated for that specific area, then penetration remains. Here you can see excessive thick root face. This one is the root. If we have face height is more, then it will also not penetrate. If we have root gap too small, then it will not penetrate. If we have misalignment, you can see here misalignment root, suppose penetration will occur here but not in this area. If you can see here, this is the root axis here, but it should be here, then it will be penetrated, otherwise not. So means if we have root face thick, if we have root gap too small, if we have misalignment, or if we have power input too low, the heat generated is too low, or the arc heat input too low. Due to all these causes, our lack of first defect occurred. Incomplete root fusion will occur. These are the 5 main causes, and these are also the causes. Remember these ones. Also, we have suppose too large diameter electrode. If we need 2 millimeter electrode, but we are using 6 millimeter electrode, then this 6 millimeter electrode will not go to the root gap. Then this problem could also occur. If we have extra small, extra large, or extra small, then this will also occur. The lack of sidewall due to arc deflection, means arc is not properly in the weld metal, then this problem could occur. The second defect is incomplete root fusion. Same, that was penetration. Now we have incomplete root fusion. Root is not properly in the root, welding is not properly fused or welded. This could be the small root gap. Same causes, more or less same causes. You have to clear the concept, what is the defect, how it occurred, and what is the root causes and how we can prevent it. Then you will easily understand all the question paper answers. If arc too long, wrong polarity, electrode too large, incorrect electrode angle, too fast speed, same problems we already discussed. Then we have root concavity. Look, we are discussing about the root problems. If we have the welding in the root, this kind of shape occurred. You can see here, this is the root, this is the ideal root. Okay, but here you can see the small concavity occurred. This is known as root concavity. You can see here we have the gap, bevel, a groove, and here concavity occurred. Why it's occurred? If the root gap too large. No, in the question, if he said in a groove there is a root concavity, how it occurred? The root gap is too small, or the lack of fusion, or none of these, etc. You can simply understand root gap is too large here. But previously the lack of penetration and lack of fusion, root gap was too small. Here is root gap too large, then this concavity will occur. Insufficient arc energy. If arc energy is insufficient, less heat, excessive back purging. Back purging is actually, I will elaborate you further, but remember this one only term. I hope you got the root concavity concept. Then we have excessive root penetration. Suppose up to there we have the root, but we welded up to there. This is the excessive root penetration. You can see here, root should be this, but if this root is known as excessive, extra penetration in the root, what could be? You can see here the cross-sectional area. This is the welding base metal, and up to there, this is the excessive root penetration. What are the causes? Excessive ampere means if we have, more or less, if you belongs to welding field, then you definitely see the welders are normally change the ampere and current, amperes and voltage, etc. More or less amperes. If they give more amperes, more heat generated. If more heat generated, then more penetration occurred. That's where they set the ampere. So if in the electrode excessive ampere, then this excessive penetration occurred. Excessive root gap, we have more gap, large gap. Poor fit up, if fit up is not properly. Excessive root grinding, if we have made the more grinding as compared to the normal one. And improper welding technique, definitely welding, skilled welder required for these jobs. Then we have root undercuts. You can see here, this is the here we have a small area which is not properly fused from the root side, is known as root undercut. How it occurred? Root gap too large. If the root gap is too large, then this could occur, means the weld metal will be elongated from one side, that will be not properly distributed. So root undercut can occur. Excessive arc energy, this is also the one reason. Small or no root gap, root face, this one is the root face. If small root face or no root face, then penetration will not here, then this area is remain, it's known as root undercut. You can see in the practical example here, these are the root gaps, root undercuts. That was root undercut. Now we have cap undercut. At top side, if the top side between base metal or within the metal, if such kind of cut occurred, it's known as cap undercut. How it occurred? Excessive welding current, same. Welding speed is too high, means the penetration, fusion is not proper, that's why. Incorrect angle of electrode is not proper. Excessive wave and electrode too large. Okay. Then we have the overlapping. As I already said you, suppose okay, this is the welding here up to here, this is the cap. If from one side it overlapped more as compared to other side, it's known as overlapping. You can see here, this could be the small one. The small one is overlapping the welding should be this phase, but extra is overlapping. If this is in the lap joint or fillet weld, and this is in the butt weld, you can see here this up to there should be a gap, but the extra one, this is the excessive weld metal, means overlapping. And then we have lack of fusion, means if the weld metal not properly melted and it becomes, these are the side of grooves, if it's not properly melted from the sides, it means that this is lack of fusion on the side walls. How it can be occurred? If there is some contamination on the weld preparation when you're preparing the groove, then some oil or mixture of water, etc. if occurred, then this problem could be. Amperage too low. If we have low current, then heat energy will also less generated. If less heat energy generated, then fusion will also not properly. If we have ampere too high, welder increase speed of travel, means if we have too high amperes, extra energy, but speed is also increased, it means that it will not properly fuse the welding. So lack of fusion will occur. Practically you can see here, this could be at anywhere. Then we have same thing, incompletely filled groove. You can see here, this is the base metal, here we have the groove. If it's not properly melted, so this is incompletely fused, and lack of side walls. If it's not properly melted in the sides, this is known as incomplete fusion. Insufficient weld metal deposited, same, insufficient weld metal deposited. Why it's not deposited? Low ampere or travel speed too high. Improper welding technique, welder is not properly scaled, so this problem could occur. Then we have interrun, incompletely filled groove. Remember, if again I would like to request you, if you are unaware about these terms which I am just telling you, giving you overview, if you want to understand all about these basics of the term, then go for the chapter 2 first, because once you will understand the term, then you will easy to understand this chapter. So we have the bottom first run or first pass, then we have the more than two passes or runs, is known as layer. For completion of any welding, we need to make more than 2 layers or root for pass by considering the width of the welding. So if the fusion not between the passes in the weld area, this is the weld area, if the welding is not completely fused between the passes or runs, is known as interrun, incompletely filled groove. I believe you got it. One run is this one, the second is this, so both runs are not diffused in each other, so this problem could be occur. Why? Because if you have the insufficient weld metal deposited, if filler wire is less, electrode has small diameter, or if you have improper techniques, so weld metal should be properly. Incomplete fusion, incompletely filled groove. This is the groove. This is the groove. This welding should be up to there, but now you can see the actual welding he performed here. It means groove is also not properly filled, so this problem is known as incompletely filled groove, when the groove is not properly filled. Then we have porosity. You can see here the small bubbles which generated and makes the discontinuity in the welding are known as porosity. The small spots or bubbles, this could be a gas porosity. In the gas porosity we will describe further. Causes, what could be the causes? Excessive moisture, if moisture are more, if we have water contamination or flux contamination, etc., contaminated water surface. Low welding current is less, arc length is too high, damage electrode flux, removal of gas shields, etc. Means gas shield is actually to prevent the welding from the environment, from the oxidation. So if it's less removed, then the external part could be entrapped in the welding and the gas porosity could be occur. So here you can also see this could be in the weld surface, or this could be top surface, or in the surface. First I am describing you all the terms and conditions and defects type concept, then I will go further detail how this can occur and how we can, what is the values. So be patient and concentrately watch the lecture. Inclusion of slags. You can see inclusion means introduced in the weld metal if any kind of slag occurred. What is slag? Any material or small thing which entrapped in the weld metal is known as slag. Like how it's occurred: insufficient cleaning between passes. We are going to pass the welding passes. If we are not cleaning properly, then we weld the next pass. So this slag will remain inside and it's called the defect of the welding. So we have to clean properly the passes. If contaminated weld surface means same oil or water contamination. Welding over irregular profile. If we have not properly make a welding profile like this, we made a groove, then inclusion of slag could occur. Incorrect welding speed is not proper, arc length is too high. Then we have same, you can see here the slag could be here or at the top surface or in the root, anywhere in the weld. Then we have inclusion of tungsten. Tungsten means we have material which normally use the electrode in the TIG welding. In the TIG welding I will elaborate in the next lectures what is TIG welding and how it's work. So the TIG tungsten electrode touch with the weld metal for the sake of welding. Some spots of the tungsten can be entrapped in the welding, which is known as inclusion of tungstens. So this is normally excessive current through electrodes, and in the TIG welding it's occurred when we touch the electrode with the weld metal, so this will be occur. Then we have the burn through. What is burn through? Burn through is like if we have this penetration, then from some areas or from the root, if more arc generated, more energy generated and is go outside, not properly welded, is known as burn through. Like this you can see up to here we have the welding, but in this area this is not properly welded. Why? What could be the causes? Excessive ampere during welding of root. We have more amperes, excessive root grinding if we made more grinding, or improper welding technique. Okay, then we have spatters. Spatters are actually the small spots of the welding which came outside on the surface of metal. It like if we are welding, this is the welding pool and we are operating the electrode. Due to welding pool and electrode pressure, some drops came outside, right, at any surface of the weld metal or the base metal. So this is the welding area. These are the spots which came outside are known as spatters. You can see here, this is the weld area, these are the spots, so it's known as spatters. Why? If we have more electricity or arc energy is more, then it came outside. If we have excessive arc length or damp electrode, means useless electrode, but we are still using, this problem could occur, or arc blow. Then we can see the arc strike. Arc strike means unwanted touching of electrode with the base metal. These are the base metal, like if after welding or before welding or whenever we pass the welding, then we unconsciously, if our electrode touch with the base metal, such kind of problem occurred. So this is known as arc strike. Arc strike with the passage of time penetrated in the metal and could cause the problem or failure of the defect, or failure of the weld. Then we have mechanical damages. In mechanical damages, grinding mark on the base metal or anywhere, or chisel mark. Then we have non-aligned two abutting bed edges. Non-aligned. Suppose if we have two double V. So double V should be a proper line, but if smaller V is not axial in axis, then it's known as non-alignment. The high-low gauge is normally used for checking the misalignment or mismatching. Then we have angular distortion, means if we are doing the welding should be in the straight path, but after the welding, due to high temperature, if there is some distortion occurred which cause the angle between two parts, is known as angular distortion. Distortion means disturbance. You can see here, this is the linear distortion, means linearly it move upward or downward almost 3 mm upside as compared to this plate. So this one is the angular distortion, means same 3 mm but at specific angle. So we need to control the defects as well. Right, now let's get overview whatever we learned from the welding defects. The standard which normally used to measure the defect or imperfection, deficiency, the defects, this is ISO 6520-1. please note down on your paper. The standard which normally used for welding imperfections is 6520. We have mainly 6 type of defects: cracks, cavities, solid inclusion, lack of union penetration, imperfect shapes, dimensions, and miscellaneous imperfections. I believe whenever I called the name of defects, you automatically recall the picture of that defect, so now it will be easy for you to understand. I hope you are understanding and enjoying the lecture. Again, I would like to request you to subscribe my channel and hit the bell icon, share with your friends, because this is completely free of cost and someone could get benefit from these chapters. Crack are actually imperfection produced by local rupture or solid state, which could be cooling or stresses. Means once we weld anything, then some stress is generated, right? Due to these stresses, the two bodies or weld metal could be disconnect, so the crack could be occurred, and this crack could be occurred in the 2 stages. One is hot crack, second one is cold crack. I will describe you further what is hot crack, what is cold crack. This crack in the shape, by considering the shape, 4 types of crack: longitudinal crack, transverse, radiating, crater, branching. What is longitudinal crack? Suppose we have weld metal. If the crack occurred in the axis of the weld, is known as longitudinal crack, right? But if the crack occurred in the axis 90-degree perpendicular axis, here, this is known as transverse crack. Then we have radiating, or crack radiating from a common point, like this is the original common point. The crack could occur here. So this crack is known as radiating crack. Then we have crater. Remember, longitudinal, transverse, radiating, and branching crack all occurred in the weld metal, haze, heat affected zone, and parent metal. If you don't know the term, then go for chapter 2 first. Watch that chapter, then you will easily understand the welding terminologies. So, but the crater is only create in the weld metal. How? If we have the weld metal and we are making the top surface of the weld metal, it always be on the top surface. By considering exam's point of view, he can say which crack occurred, only crack occurred in the weld metal, crater crack. Second question could be, on the top layer of the welding, which crack could occur? Then you can simply take on the crater crack. Remember. Then we have the branching crack. Suppose one crack, main crack is this. From main crack, different crack induced. So these are the branching cracks, right? He he said that crater cracks are found only in weld metal. Remaining all four cracks, longitudinal, transverse, radiating and branching crack could be in the haze and parent metal, right? By considering the nature of cracks, we can categorized in these four things: hot crack, precipitation induced crack, cold crack, lamellar tearing. Let's discuss about the hot crack. What is hot crack? You can see when we weld, then the weld become cooled down. Due to solidifications, different stresses induced, and due to these stresses, this kind of crack could occur. That's why it's known as hot crack or solidification crack. This could be in the stage of solidification, means usually along center line of the weld and result of solidification process. In the solidification process, or this could be in the liquidation process, right? Liquidation process. What is liquidation process? Before the solidification, we have molten metal here in the welding, so it's known as liquidation cracks, right? Why it's normally occurred? Due to carbon or impurity, sulfur, if the sulfur contents are here, or if the depth to width ratio of the groove is, like here we have, this is the depth, this is the width. If depth more, width less, then this will be known as narrow groove. Due to narrow groove, this crack can occur, or heat flow condition is not properly, start and stop, again and again, start stop welding. So if the continuity of the welding is not proper, then this crack could occur. Same in the steels, normally it's occur due to sulfur and phosphorus, and the thermal shrinkage of the cooling weld bead can also be occurred. Here you can see sulfur enriched liquid film. Here we have the sulfur, then in the welding, once solidify occurred, due to sulfur and contamination, this kind of crack can occur. And shrinkage of grains are become shrinkage, like after welding due to stresses, some shrinkage occurred. So due to shrinkage, the both metal extract to each other, then this crack could induced. Okay, it's important that fabricator should cover entire area clean first. There is no scaling, no oil or grease on the weld metal, and no carbon or sulfur to prevent this one, right? Then we have hydrogen induced crack. It's also known as HIC. Hydrogen induced crack is also type of, we can say, cold crack, right? Cold crack. What is cold crack? Once we done the welding, then due to hydrogen, because hydrogen is unwanted but always remained contamination in the welding, so hydrogen induced in the welding, with the passage of time, this hydrogen pressurized and distract the welding and cause some crack. That's why it's known as hydrogen induced crack. Hydrogen induced in the weld metal means penetrated in the weld metal. So the second reason to call this cold crack is we can't see the hydrogen induced. That's why it shows after few months, even a year or many years after, this kind of crack could occur. Then we have toe crack, hydrogen induced. This is in the root, you can see here. Then if the crack occurred in the toe, here we have the toe, then it's known as toe crack. How the hydrogen can be induced? Remember these four things. Hydrogen level, if the hydrogen level is more than 15 milliliter per 100 gram of deposited metal, we are doing the welding. At every 100 grams, if the hydrogen level is more than 15 milliliter, this is against the standard. We have to maintain the hydrogen level, means we have to cover the weld metal and properly maintain the contamination free area. Also we need to check that it is properly shielded, the gas shielding is properly being delivered. Then we have stresses. Stresses should not be greater than 0.5 of the yield stress. Then we have the temperature of the weld metal. If it is less than 300 degrees Celsius, then it could be occurred. Then we have susceptible microstructures, means hardness level. If the hardness level is greater than 400 HV, then this kind of crack would occur. Hydrogen cracking, low temperature, hydrogen content, high stress and microscopical. Okay. Then we have lamellar tearing. What is lamellar? We are studying only the first crack in the detail. So please note down all these important points. This is the important. You can see here in the rolling, if we are rolling any plate, then some kind of irregular crack occurred, right? You can see it. So these are known as lamellar tearing. In the picture you can see easily here. Such kind of cracks are known as lamellar cracking or tearing. How it could be? Use clean steel, combination of joints should be proper. These are the two main problems could occur. Then we have cavities. What is cavity? Cavities could be the discontinuity in the weld metal. It could be from two sides, two reasons: gas cavity and shrinkage cavity, due to shrinkage and due to gas. Let's see from its detail. Gas pores. If some gas is entrapped or induced in the weld metal, then it will create a cavity, a space, which makes the discontinuity of the weld metal are known as gas pores. Means it could be a spherical shape trapped within the weld metal. Any gas cavity is for essentially spherical shape trapped in the weld metal. So gas cavity can be present in the various form: isolated, means one by one, uniformly distributed in the entire area; clustered form, we have the clustered, right? Linear porosity like this, elongated cavity like this, or surface pore only on the surface pores, right? Causes. What are the causes? Damp flex, flex are not properly. Preventions are, we used to dry the electrodes in the good conditions. We have the dryer and the bakers. Then we need to dry the electrodes, which normally temperature maintain 350 degrees Celsius for 2 to 3 hours. It depends on the type of welding electrode and the welding material. If the grease or hydrogen water contamination, then we need to clear these from the surface. If air entrapped in the gas, then we need to check the hose connections. Means air should not. We are talking about the cracks, cavities, causes and preventions, right? If we have incorrect insufficient dioxide filler parent material, we have to sufficient dioxide activity. Means if it is oxygenated to great arc wall length, then we need to reduce the arc wall. Gas variations from the priming paint surface. If we have the painted surface, then the gas could be entrapped and cavities could occur. Identify the risk of reaction before heat treatment. We need to clear all the painted surface areas. To high shielding flow gases results the turbulence. Means if the gas flow of gases is too high, then the turbulence could occur. So we need to optimize the flow rate. Then we have wormholes, cavities. In the cavities we have wormholes. Elongated and tabular cavities found by trapped gases during solidification of weld metal, which can occur singly or in a group. Elongated and tabular cavities means during the solidification some gases can be entrapped in the weld metal, which could be occur in a single or in the form of group. It's known as wormholes, right? So causes could be gross contamination preparation. Prevention, introduce prevailed cleaning procedures like this. We don't need to focus on these more things, just need the concept. Surface porosity. What is porosity? As I already explained, gas pore that breaks the surface of the weld. This is the continuous surface. If it is breaking from any point, it's known as surface porosity. I think you are enjoying my lecture, but the lecture become boring because I am boring. Okay, let's have a 3-second break, 5 seconds. In this 5 seconds, just close your eyes, get a long breath, then we will start. 3, 2, 1. Okay, now this is the trick and technique which I teach you today. If you become bored while doing any job, any work, then stop the job, get inhaled for 5 seconds, close your eyes, maximum inhaling, then you will feel relaxed. After the relaxing, then you can start the work. So let's start the further porosity works. If the gas pores occurred in the surface of the weld, which breaks the weld metal, is known as porosity. This is very simple, by the way, don't be worried about it. All the causes and prevention are almost the similar. You should have not worry about which causes are for specific defect and which causes are different from defect. No worry about it. Just gone through with the lectures and note down the problems, then we will understand which causes could be. In the paper, the minor causes could not be the part of the paper. They will give you a major cause, like lack of penetration could be in the root, could be due to small gap, due to large gap, due to lack of fusion, etc. You can simply understand with your concept. If it is not properly penetrating in the root, it means that the root gap is very small. Then you can simply tick it. So first clear the things, then you don't need to remember all these things. Just clear the concept. I again repeating you. So porosity could occur due to same damp electrode, low fluxing, sulfur, loss of shielding gas, etc. And the preventions are this. Then we have crater pipe. You can see this is the top surface of the any welding, right? At the end, some kind of spot generated. This is known as crater pipe. This could be occur only in the weld metal. This is very important question by exam point of view. Which defect could occur in the weld metal? Crater or crack or spatters. You can simply take on the crater, right? So this will always be end of the weld run. Why this occurred? Lack of welder skill and inoperative crater filler. Fill the material which you are using. TIG welding due to low heat input. If we have less heat input, then this problem could occur. Then we have solid inclusion, as I already explained to you. Let's go directly here. Solid inclusion means during welding, if flux or electrode part or any part incorporated in the weld metal is known as inclusion. So this will be always in the solid or gas, whatever could be. If it's the solid, like electrode flux can be entrapped here, then when we perform the RT or UT, normally RT, then we can see okay, here we have the spot. It means that some inclusion is here. You can see these are the result of RT. Black spot is the slag inclusion. Slag trap during welding, which is irregular shape, so different from appearance of gas pores. Incomplete slag removal. Slag is not properly removed, so we need to improve the slag removal from every interpass. Slag flooding, entrapped of slag in the work surface. You don't worry about these things. Just one thing you are focused that there is only one main point of every different defect which differ from others, like slag inclusion. Slag inclusion means some kind of slag induced in the weld metal, so slag inclusion occurred. Remaining things are almost same. Slag, you have to remove the slag first, and arc length should be proper, etc. So if the flux induced in the weld metal, it's known as flux inclusion. Means we have the electrode, beside the electrode we have flux. So if the flux induced, or flux could be any gas as well, So this could be the flux inclusion. Then we have oxide inclusion. Any oxidation or oxygen entrapped is known as oxide inclusion. Then we have tungsten inclusion. You can see here the small spot. This is normally in the TIG welding. This is very important question. The tungsten inclusion could occur in which welding defect? It could be which welding process? It could be TIG, tungsten inert gas, right? This is the important question. Note down on your copy. So tungsten inclusion is only entrapped in the TIG because we have tungsten electrode. When we touch with the base metal for the welding, then some kind of spots could occur which entrapped in the weld metal. And normally remember one important thing as well. When we perform the RT, radiographic testing, I will explain you in the coming lecture NDT chapter what is RT, what is UT, MT, PT. These are all the important techniques to identify the defect. So in the radiographic testing, tungsten has light impression. You can see here white, small white, light impression. But originally tungsten is solid inclusion and it is more dense. You got my point? It means on the radiographic film, tungsten is more dense, but its impression is light. So if any inclusion or any weld metal is less dense, its radiographic film will be more clear, more dark. If it is more dense inclusion but radiographic film will be less dark. So this is also by considering the exam's point of view. In RT film, if we have more dense material or inclusion, then less dense film could be generated. Vice inverse proportion, right? These are the causes. You can easily read only one time, don't worry about it. Then we have lack of fusion not properly on the sides. This could be due to low temperature, low voltage, and more speed. Weld metal is not properly sulfur phosphorus here, so we need to clean. Low heat input, molten metal is not proper, oxide, excessive inductance, etc. Then if the lack of fusion is between the inter-run fusion, means this is the first, this is one pass, this is the another pass. Between the inter-runs, if this kind of problem occurs, then we can say it lack of inter-run fusions, right? This could be low arc current, high speed, inaccurate bead placement. So preventions are these. Lack of root fusion, we already discussed from the root. If the fusion is not properly, then it's known as lack of fusion. What could be the causes? Low heat input, excessive inductance, MMA electrode too large, use vertical down welding, large root face, and against this, these are the prevention. Don't worry about it, just understand it. Small root gap, this is the important one. Why it's occurred? Small root gap, in the incorrect angle, etc. Then we have lack of penetration. Same, we have the double V. Here we have the root, but in the root there is no penetration occur. It means there lack of penetration or incomplete penetration. Why? It's normally thick root face. Root face is more high, and we can say low heat input. Okay, and electrode too large. Diameter is more, but thickness is less. Root thickness. So this kind of problem could be occurred. Then we have incomplete root penetration. Same, if the root penetration is not properly completed, it could cause this problem. Then we have the undercuts. Undercuts could be irregular groove at toe and run the previously deposited weld metal of welding. Then we have excessive weld beat, means we have the excessive weld metal acceptable up to here, but if it's go beyond this limit, this is known as overlapping of or excessive weld metal, which I already explained to you. This could be shallow edge preparation, incorrect electrode size is not proper, traveling speed is too slow, incorrect electrode angle. Then we have excess penetration, already explained to you. If the penetration is more, as compared to the original one, then it's known as excessive penetration. Okay, then we have same overlapping, the poor electrode manipulation, retain the welder, high heat input, incorrect position of welding, wrong electrode. Then we have linear misalignment. If the both grooves or both terms are not in the linear position, then it's linear misalignment. Then we have angular distortion. If you have two weld metals and angularly it's distracted, then it's known as angular distortion. Then we have incomplete filled groove. Already explained to you, if the groove is not properly filled with the filled metal, then it's known as incompletely filled groove. It could be insufficient weld metal and irregular weld bead. Then we have irregular weld bead width. You can see here up to there, some bead is coming in this area, some bead is coming in this area. So bead width is not properly, this is known as irregular bead width. Why it could be occur? Severe arc blows, irregular weld bead surface not properly grooved, and arc blow means excessive arc. Root concavity means like this kind of defect could occur in the root gap, this circular. Okay, why? It's normally insufficient arc power produced, incorrect preparation, excessive backing gas strip, lack of welder skill. Against this, we have to focus on the work on WPS, reduce gas temperature, pressure, retain welder, etc. Then we have the burn through during the welding. If we have excessive ampere of welding, then some kind of spark or the spot generated, which normally be the gap of the continuity of the welding, is known as burn through. Collapse of weld pool resulting in a hole. Collapse of weld pool means distraction or distortion in the weld pool. Why? If it's insufficient travel speed, excessive welding current, lack of welder skill, excessive grinding phase, excessive root. Only the small areas remaining, don't get bored. We are just going to at the end. Then we have stray arc or arc strike. Remember both terms, arc strike or stray arc. Unwanted touch of electrode with the base metal is known as arc strike. This normally with the passage of time penetrate in the weld or in the base metal, which cause the defect. Poor access to the work, access is not proper, missing insulation of electrode holder to torch, failure and loose current, etc. Then we have spatters during the welding. If the temperature is too high, welding pool, metal pool is more liquid, or the electrode is too near to the welding pool, so these are the spatters generated and came outside from the groove, and this defect would occur. We have to clean with the grinding. High arc current, long arc length, magnetic arc flow, damp electrode, etc. Wrong selection of shielding gas. Okay, we have miscellaneous imperfections like grinding mark during the welding and grinding. Some mark could be occurred, chipping mark, chipping during the chipping and cleaning, or under flushing, lack of thickness of the workpiece due to excessive grinding. If we perform the excessive grinding, then it's known as under flushing. Then we have the misalignment of opposite runs. Misalignment occurred, temper color, etc. Don't be worried about it. You can see here, these are the root cracking, TIG welding, etc. Then we have the acceptance criteria. By considering the CSWIP, we don't need to go in the detail. Just be focused on the original visual inspection, and once in the conclusion, if you have idea of all the cracks, all the defects of welding, then why it's occurred, how we can prevent it. Visually, you simply need to inspect, and you simply need a record and inform to the welders. This is the actual job of welding. I hope you learn something new from my lectures, and I believe this will be the beneficial for you. At the end, I would like to request you to subscribe my channel and be in tune with me for the upcoming lectures. And remember, share and comment. Also hit the like and bell button to after subscribing my channel. Definitely this will be helpful for you in the future in the actual exams. Thank you. Have a nice day.